So we're going to start by finding the recursive rule to model the geometric sequence we have here. So recursive rule is what we're looking at right now. And the numbers we have are 5, 10, 20, and 40. And in order to get from one number to the next, it looks like to get from 5 to 10, we multiply by 2. To get from 10 to 20, we multiply by 2. To get from 20 to 40, we multiply by 2. So then my formula is simply going to be any number g of n is going to be equal to 2 times whatever the previous number was, which we can represent as g of n minus 1 for the previous number. We're finding any number here. We take the previous number and we just multiply by 2 as we found here. That's how we get g of n equals 2 times g of n minus 1. And if I look at my answer choices, the choice that matches that is choice A, not B, C, or D. It's choice A. Okay? So that's the recursive formula. It just tells us the step to get from one to the next. In this case, that step was multiplying by 2. Now let's go ahead and find the explicit rule to model this sequence. So we know we're multiplying by 2, and it's the same sequence we have down here, 5, 10, 20, and 40. We know that we multiply by 2 to get from one to another, so our growth factor is going to be 2, and our starting value, our initial value, is going to be 5 there. So then the formula should look like g of n equals 5, our starting value, times 2, because that's what we multiply by each time, and we do that to the power of n minus 1 to figure out how many times we need to multiply by 2. Because here, if we go back up here, we multiply by 2 once, we multiply by 2 again for the next term, by 2 again for the next term. So the number of times we're multiplying by 2 depends on what our input of this function is. That's why we raise it to the power of n minus 1. The 5 came from our initial value. Our starting value was 5. And then the 2 came from our growth factor. And so we can find any term by taking our starting value of 5 and multiplying it by 2 to the power of n minus 1.